Okay, here's somebody sent in a really good question. This is, I think, number 15 from chapter 5.5. And the question is here, you've got these different letters and you want to know how many different 10-letter words, real or imaginary. So they don't really have to be words. They can just, it's a 10-letter string, can be formed from the following letters: HOZ, GZ, MOU, XW. And the tendency would be to say, for the first letter, you have 10 choices, so that's 10. For the second letter, you have 9 choices, that's 9, 8, 7, 6. You multiply all those two things together, and you get the total number of choices. That's 10 factorial, right? But what kind of screws it up for this problem, why you can't just do that, is that you'll notice that some of the letters are repeating. Like there's 2 O's, right? And what else? There's 2 Z's. Okay. So what you have to do is, let's see, I think I've got a picture here. So for example, in this word, you want to know how many different ways can you change around the word sassy, right? But the problem is you've got 3 elements, 3 S's that repeat the whole time. And in any given word, it doesn't matter whether it's sassy or just some other word with those letters in it, you can always get the same word by changing the red S and the green S, right? Or the blue and the red, right? And how many different ways are there to order those 3 S's? Well, you've got 3 choices for the first one, 2 choices for the second one, and 1 choice for the third one. So that's really 3 factorial. So, or 6, right? 3 factorial is 6. So there's 6 different ways to always write the same word with the colored S's in different order. Okay, and it doesn't really generate a new word or a different word. It's the same old word. It's just that you're using a different S in a different place. So that's the same idea here. So what we want to do is, I wish I could write on the screen. Let me see if do I have those tools? No. What we want to do here is we want to take 10 factorial, which is what it would be if all the letters were distinct, okay? And then we want to divide by each element that has a more than one representation in the list here. So there's 2 O's, so we would divide 10 factorial by 2 factorial. We'd also divide it by another 2 factorial because the Z's are doubled. Okay. Now, if you had something strange like 3 X's, right, it would be 10 factorial and then divided by 3 factorial. Okay. It's however many times that letter repeats. So I hope that helps a little bit on this problem. Again, I think it's really easy if all the elements are distinct, but here the trick is that there's some elements that aren't distinct, the O's and the Z's. Okay. So I hope that helped a little bit. Let me know.